Good morning, everyone. My name is Morgan. With me today is Dan, Bob, Alec, Ben, and Craig. We are Team 12, and this is the Canine limb brace design, and we would like to introduce you to Wendy. So our project was broken up into 3 phases over the course of the academic year. The first phase really encompassed learning, understanding the problem with meeting Wendy herself and taking her to the vet for her initial x-ray. The second phase was all about design, making several different prototypes until we reached the final design. And the third phase was about taking that final design and testing it through FEA analysis and gait testing. So a little bit of background on our project. Wendy is a 1-year-old Bernese Mountain Dog. She's approximately 85 to 90 pounds. She was born with a deformity in her front right limb, and because of this deformity, she rarely uses the affected limb and instead walks on the other 3 limbs. This subjects her left shoulder to extra weight, which can possibly cause joint problems and fractures within the future. This means there could be a decrease in her life expectancy. So like I said, for the first phase of this project, we really wanted to understand her deformity. So we took an initial x-ray and found several anatomical problems within her front right paw. As you can see on your left, there's her non-deformed paw, and on your right is her deformed paw. There are several twisted phalanges. 2 metacarpals are fused within one of her paws. This is where she does place the weight. So when she does put the foot down, this is the surface area she puts it down on. The main problem, though, is that there are several disarticulated carpals, or wrist bones. So this splits the radial and ulnar bones into 2, with half the paw growing on one side and half the paw growing on the other. There is a lot of space in between the radial and ulnar bones on the right forearm. And because she only puts her weight on the radial side of the paw, she is not using the ulnar side, and this has caused her ulnar bone to atrophy, meaning that her body is reabsorbing the calcium from the bone. So the overall goal of this project is to fabricate a prosthetic or a brace in order to help Wendy redistribute her weight on her front end and help improve her mobility. Now to talk about the design is Dan Garman.
All right, so now that you have a thorough understanding of the problem statement, I'm going to take you through the beginning portion of the design phase, starting with the 3D scanning process. So to your top left, you can see actually a 3D point cloud. It's zoomed out. So this was obtained using a Faro 3D handheld scanner. So this was done by hand. Unfortunately, this was unsuccessful for measurements. As you can see in the bottom right image, the bottom surface is relatively flat. For this reason, we couldn't actually use it for design. So we had to go to hand measurements from this point. So furthermore, now we had to determine between a prosthetic or a brace design. So to your left, you can see a drawn full prosthetic design. So 2 key features I'd like to point out with this design are full functionality, as this would totally replace an entire limb, and also ankle flexion movement. So we wanted to simulate that of an actual paw. So this is contrary to the brace design, which is to your right. Some key characteristics of this design I would like to point out are the Velcro straps, which would act as a fastening system, a breathable design, which in this image you can see vents that we incorporated. We could also use holes cut into the design itself. So a rigid outside, possibly a plastic material. Pivot points, again, to offer that ankle flexion movement. And finally, some type of rubber molding in order to increase slip and shock resistance. So after speaking with the owner and the veterinarian, it was actually undesirable to the owners to remove the limb. Surgical intervention was not desired. So for that reason, we decided to go with the final brace design. So furthermore, now that we knew we had a brace design, we needed criteria. So we use this for design generation. So before you, we have a table with requirements, the implementations and measures. So the requirements are actually what we needed. The implementations are how we were actually going to go about achieving these requirements, and the measures were checks we used in order to ensure we met these requirements. So going down the list of requirements, we have strength and durability, weight consideration, a fastening system, form fit comfort, a breathable design, shock and slip resistance, stability of the leg, and ultimately we want an improved mobility. So taking you through one of these, for example, we obviously wanted a fastening system. This would be implemented by including the Velcro straps with cut notches in the rigid body of the design. We would measure this by ensuring we have limb containment. I will now be followed by Bob, who will take you through the second portion of the design phase.
So now it's time to discuss the Autodesk Inventor portion of this brace design. The brace was fabricated within the software with the design criteria as previously mentioned by Dan. In committing to a 3D print here at the university, we were restrained to an 8-inch maximum limit within the three-dimensional plane. As denoted by these images and the dimensions, this 8-inch criteria is met. Now onto the 3D model for printing. So on the left-hand side, I'm going to take you through a brief timeline of the 5 prototypes in which we have considered. Each print was printed, attached to Wendy, and then refined for a later prototype. Specifically, prototype 3 is unique because we attempted to accommodate Wendy's existing 45-degree angle of inclination within her paw by rotating the bottom portion of the brace. However, after consulting with the vet, Dr. Stephen Pryor, he informed us it's best not to accommodate any sort of existing deformation. And thus, we went with a straight design for prototype 4. Prototype 5, as deemed our final design, is very similar to that of prototype 4. However, there was a width reduction. And considering the design criteria, most notably all of them are met except for the pivot points. We elected to eliminate the pivot points because Wendy's ankle flexion is already severely restricted. Now onto the finite element analysis experimentation. So the Autodesk Inventor model was imported directly into this Abacus software at several conservative design loading arrangements such as the Velcro straps, paw orientation, and a contact force with the ground. The test was we ran the test, and the stresses and displacements are resulting up there. The blue-green areas are areas in which the potential failure threshold was not met. However, there was one area located along the lip in the left-hand portion of the figure in which we anticipated the failure. Thus, we have eliminated the lip from our final design. Now on to Alec with the gate testing.
All right, so the next step in our design phase 3 was gate testing. This was done to test for results. So what gate testing is the test for joint motion and force motion in Wendy's limbs. So by doing this, we did 2 types of testing. Kinetic testing, which is the use of force plates to see the weight distribution, as you see in the top right. On the bottom right, you see a force diagram. And on the left graph, you see Wendy's left paw hitting the force plate. And on the right, you see her right paw hitting the force plate. You can see that on the left, she's taking about 2.5 times more of her weight, which is what we're trying to correct. So the second type of gait testing is kinematic testing, which is the use of a gait mat and paw print analysis techniques to test her stride lengths. So this is done with 3 trials, and on the video on the bottom left, you see Wendy walking across the gait mat, and then on top or on the bottom right, you see Wendy's paw prints being picked up by the multiple sensors in the mat. So to put this to something, we used Trigger, which was an 85-pound male yellow lab, as a control test subject. And these tests were done before Wendy had the brace on, 1 week after we put the brace on her, and 3 weeks after we put the brace on her. So to get into some results, for kinetic walking testing, as you see on the right, there's 2 pictures of Wendy and Trigger walking across the force plates. Trigger, Wendy before the brace, and Wendy with 1 week of brace activity is shown on the bar graph. Denoted by the red box is Wendy's affected paw. As you see on the gray data, there's about a 5 to 6 pound increase from only 1 week, which is about 2% of her body weight. And what this does is it aids in the distribution of a weight off of all of her other unaffected limbs. And Ben's going to continue talking about the kinetic testing.
So the second kinetic test was performed with the subject standing stationary, and with the use of the force plates, we were able to obtain a % of body weight distributed on each limb. So if you look at the control, you can see that he distributes his weight evenly on his forelimbs at around 29%, and as the same thing on his hind limbs at around 21%. Now, before the brace was implemented, you can see that Wendy's results are severely affected by her deformity, as she only distributes about 11.5% of her weight on that deformed limb. And you can see that her front left limb is taking most of the load at 39%. So 1 week with the brace, you see a slight increase in weight distribution on her right deformed limb, but we still see that her left limb is taking most of the load. So 3 weeks later, we see that 2% increase in weight distribution on her front right limb, and we also see that she's starting to have a uniform distribution of load across her 3 healthy limbs. So for the kinematic testing, we measured stride lengths, specifically hind to front, hind to hind, and front to front. Now the results we got from our control showed that he had this equivalent stride lengths on both the right side and the left side of his body. Now before the brace, you can see that Wendy's stride lengths are significantly shorter than the controls. This is due to her deformation. So 1 week with the brace, we see an improvement in stride lengths getting closer to the control, and then 3 weeks with the brace, you see that in the stride lengths are approaching the control animals. So for the project delivery, here you can see the improvement in Wendy's walking with the brace. We have before the brace, 1 week with the brace, and 3 weeks with the brace. And now Craig will talk to you about continuing improvements.
So for continuing improvement, a wireless force sensor we place at the bottom of the brace, and this will be used to capture Wendy's amount of force over time. After our results, the weight distribution will be in balance when both front paws are at 29% of each weight. Improvements between weeks 1 and weeks 3 give us an estimated balance at 17 weeks. To wrap up, the final brace assessments, as you can see, all the requirements were adequately met except for strength and durability. Here you can see where some cracks have occurred at the back of the brace, and also form, fit, and comfort could have been improved. Here are the details of the budget we received by the school, and we were allocated underneath. At this time, all the goals have been met, and I will lead us into a conclusion. Our team has successfully built a brace that is both comfortable and lightweight while providing greater mobility to Wendy. The results prove that just after 1 week, the brace has been successful, and this has all been accomplished under budget. These are our sponsors we would like to thank. Thank you. We'd now like to open the floor for questions.
It's got to be one out there.
Did you view the requirements as fully independent, or were there dependencies between some of the requirements?
Just a clarification on your question, the brace requirements, correct?
That's right, the requirements you listed.
Yeah, I would say, I guess naturally a lot of them kind of coincided, being that the body of the structure was a totally fully rigid design. So again, the notches where the Velcro straps were incorporated but they all kind of tie in together. We had considerations with the lip in front as well. And again, I mean, a lot of the considerations kind of fall under the main body itself, but other additions are separate, such as the rubber base and the padding in the interior.
Did that answer your question?
Yeah. Something you thought about? Is it something you thought about, the connectivity between the requirements?
We definitely thought about the connection between all the different requirements, with the main one being strength of the main brace itself. We could see that through our generations. As you could see, the first generation was severely cracked and thin. So we were able to develop that through our generation of prototypes.
Hi, did you consider a traditional thermoplastic orthotic instead of a 3D printed orthotic?
Yes.
No, we really just were considering any sort of material in which we could print here at the university, and PLA plastic was our best option.
Okay, if you have a larger budget, like $1,000, do you have something different with the design?
You
If
have
we
more
had a bigger
money.
budget, what would we do with the design?
Yeah, I mean, I think we would have better material selection, because we'd be able to print outside and possibly look at other options instead of printing 3D plastics.
Actually, there's room for one more if I do outside.
Okay.
The person next door. Oh, okay. Questions.
Initially, when you first started out, you said that the bones of the fall were separated, and that would be a deterioration later on in life for the dog. The brace, was that any of that taken into consideration to hold the bone closer together as the fall or leg is?
Absolutely. So one of our, a part of our design is a compression sleeve, which kind of pulls her two bones together, not so much that she's in discomfort or pain, but enough that she now places both paws on the ground, increases the surface area in which she's distributing that force now. So she's going to start building up muscle, and her body's going to start redepositing that calcium within that ulnar bone.
Any further questions? Great, thank you.